In this video, we're going to keep looking at the key features of functions. And what we're going to look at are minimum and maximum values of a graph. So let's first by making a definition here. So a maximum is the highest y value on a graph. Now we're dealing with functions. A lot of people tend to have trouble with this because they feel that it's the maximum point. Well, you're close, but it's the maximum y value. We're looking for the biggest output value. Let me reword this. We're looking for the biggest output value that we can get from a particular function. Now, we use this in maximization problems where we're trying to find the biggest area of something. So it's the y value, not necessarily the point. The point does mean something. So that's the big thing we're looking for. Now, the question becomes, how do we know it's a maximum? Now, there's some things you can do in calculus to look at this, but since this video is meant for Algebra 1, we're just going to use it as a turning point. I used that in the previous video. So what we do is we look at the graph, and if it's going up before the point and then going down afterwards, it's a maximum. So I refer to this as a turning point. If you see that it's at the top, that's then a maximum. So that is about as in-depth as we're going to get. We're not going to get into the calculus stuff, all that. Just keep it kind of straightforward. Now, the big thing to note is the maximum is located at the x-coordinate and has a value of the y-coordinate. So here's what I mean with that. So our maximum value here is 4. The biggest value we're going to get from this function when we plug in a number is 4. And it's located at 0. So when I plug in 0, that gives me the biggest number. So what we would say is we would say the maximum is located at x equals 0 and has a value of y equals 4. So that's how we're stating that when I plug in 0, I get the biggest possible y value of 4. So that's what a maximum is. Now, a minimum is basically the same thing, but it's the lowest y value on the graph. Now, again, we're looking for the lowest output value. The lowest output value. So again, we're looking at the y value. We're not looking at the point. Now, the point does mean something, but the lowest y value we can. So how do we know it's a minimum? Again, keeping our definition pretty straightforward. We know it's a minimum when the graph is going down. It's decreasing before the point, and it's increasing after the point. So we see this change here. Again, it's a turning point where we change directions. And like before, the minimum is located at the x-coordinate and has a value of the y-coordinate. So in this particular case, we would say the minimum is located at x equals 0 and has a value of y equals 0. So that's it. That's a minimum. And that's about as in-depth as we're going to get today, is we're just going to look at minimum, maximum. So let's take a look at a couple problems, and that's it. So here I've got 4 graphs, and we're going to determine if the graph has a maximum, minimum. If so, state the location and value. So we're going to say located at x and a value of y. So if I'm looking at this first one, think to yourself, is there a turning point? Does the graph change directions? Well, no. This graph is a line, it's a linear, it doesn't change direction. So there is no maximum minimum. It's going infinitely in those directions. So we would say none. And this can happen. We can have problems that don't have a maximum. They don't have to have one. Now, if I'm looking at number 2 here, I can see that this is clearly a minimum. Clearly a minimum. I see the change from decreasing to increasing. So I know that it's located at x equals 0, and it has a value of y equals 1. So it's located, the x that gives me the smallest value is 0, and the smallest value I get is 1. Let's look at number 3. This one should be obvious. I see the increasing, then the decreasing. So this has to be a maximum. So let's see, it is located at x equals 0 and has a value of y equals 2. Now, number 4 is a little odd. Let's think about this one. So it kind of looks like it might be a minimum because I see this kind of curve shape here, but this doesn't actually change directions. This graph is increasing. It's kind of like a vert ramp. It just keeps increasing and increasing and increasing. Since there is no change in direction in this exponential curve, this is none. There is no maximum, there is no minimum, just is what it is. There's no change in direction. Now, the last type of thing we're going to look at is what happens if I'm given a table? Can I determine if there's a max or a min from there? And the answer is yes. What you're going to do is you're going to look at your y values. So here I have this table, and I see I go from 1 to 2 to 3 to 2 to 1. Well, what's happening from 1 to 2 to 3? So from this section right here, my graph is increasing. I see that it's going up, 1, 2, 3. And then afterwards, let's change colors here. So afterwards, I see from 3 to 1, what's it doing? Well, it's decreasing. So we look back at our definition. Is there a change in direction? Yes, there is. It's going from increasing to decreasing. So increasing to decreasing, that means I have a maximum. So it's going up, then down. So it's a maximum. It's located at x equals 0. So that would be this point right here at x equals 0 and has a value of y equals 3. Oops, switching that. There we go. 3. Okay, let's try the next one. So here I go from -3, -4 to -5, and then back to -4, -3. So let's see. From here to here, what's happening? Well, the graph is decreasing. It doesn't look like it, but remember, the more negative we get, the smaller the number. So it's actually decreasing. And then from -5 back up, what's that doing? Well, I just said it. It's increasing. So since I'm decreasing, going down and back up, that means I have a minimum. So my minimum here is located at x equals 0 and has a value of y equals -5. Now, not every max and min on a table is going to be located at 0. It's just the convenience of this problem. But that's it. That's how we determine maximums and minimums from a function.